I created a practical and functional motion tracker from Alien Isolation. It took 3 months, a lot of R&D, and some of my mental sanity too. This begins with our client Craig. He inquiries us about wanting to build a cosplay prop of the motion tracker from Alien Isolation. Now, what is the motion tracker? The motion tracker is a modified device that the player can use to track the alien along with other entities like working Joes and like pretty much anything that moves. It is probably one of the most useful items you can find within the game. Back to Craig, he recently purchased a 3D printed kit as a base, and he would like me to incorporate the electronics as he does not really know much coding and doesn't really have the time to learn how to do so. Luckily for me, I'm an engineer and I'm good at this. The parameters are as follows. The device can be turned on and off by a metal toggle switch. The screen can show an animation, the motion tracking, multiple animation screens. The screen can be changed to a digital clock, so the prop can be used as a practical display piece. USB-C charging. The dials can be used to control the device. The motion tracker has a single red LED at the bottom. He would like that too. And finally, sound. Now that the parameters were set, you can now watch me unbox this lovely package that he sent me of the initial 3D printed kit. He sent me this in a box. It came from the UK. I'm not sure exactly what it is. If anyone can let me know down in the comments what this is from, I would appreciate that. But after removing all of these pieces from the box, I was able to confidently deduce that I would not be using any of this and instead be designing my own custom enclosure because I am stubborn. But hey, now I got an excuse to put my really cool cat skills to use. So here's the full model. Please, no need to applaud. Let's get rid of those electronics real quick. Boo-boo. And now let's get rid of all these stupid screws. And now let's break this model into its individual pieces. Now let's get into the main enclosure. The main enclosure stores the bulk of the controller electronics, those being the Raspberry Pi, ESP, dials, speaker, the screen, and the audio module, which also means that it went through the most design changes and had the most reprints. I had to precisely model everything perfectly to fit and house the electronics while also watching out for hazards. Can't have the electronics be rubbing up against one another, as that could possibly cause a short circuit, which can destroy the entire system or just one component, which did actually happen. I'll explain more later. Just keep watching and we'll get to all of those mistakes at the end. I was able to import models of almost all the electronics from sources online, which made the modeling way easier on my part. Now on to the second most complex part of this design, the battery enclosure. The battery enclosure consists of two parts, the enclosure and the cover. These are the only other highly designed parts to fit the electronics. Once we remove the hardware and peek inside the enclosure, we can see the electronics, those being the battery electronics and the LED. This rechargeable battery holder is connected to a red USB-C breakout board, so I could design the charging cable to run through the back of the device where it is well hidden. Wires from here run up into the main housing, which power the entire device. Now onto the rest. These are purely cosmetic, or they serve little purpose, and I'm not going to bore you by going over each of them. Instead, I'm going to give you this cool little time lapse of me putting together a few different pieces using screws and heat inserts to assemble the whole thing together. I must say, heat inserts are a dream come true. They are amazing for 3D printing, and I recommend them to anyone who's trying to include screws and separate pieces in their 3D prints. Now, before we get into the mistakes, let me go through the electronic hardware and how everything kind of communicates with one another. The first thing the user is probably going to see is the 4-inch display screen. That display screen is connected to a Raspberry Pi via the 40 GPIO pins to allow the screen to be controlled by the Raspberry Pi. Now, I ended up configuring a lot of code with the Raspberry Pi, but I also configured a lot of code with the ESP32C6. The ESP was the main input and output controller of the entire system. It took the inputs from the rotary encoders and sent signals out to the LED, the audio module, the Raspberry Pi even, and the Raspberry Pi could send signals back to the ESP, which the ESP could then send signals out again to, the audio player and stuff. Last thing is just the main power system, that being the rechargeable battery holder that went into a toggle switch that is conveniently placed exactly where there's a toggle switch on the actual device, and that leads back into the entire system, powering the whole thing. All right, now onto the part that makes us feel human, the mistakes. We first got me spending a whole lot of hours on this lovely Raspberry Pi desktop flash screen that I could not get rid of. Well, I mean, I did because, eventually I had to get rid of it. I then also ran into an issue regarding this, whatever this is. I mean, I don't know why it's so pixelated. The graphics ended up so bad, but I reverted a few lines of code and then kind of changed a few things, and it ended up getting the high quality that I wanted. And as I was nearing completion, the last thing I had to do was rotate the screen 90 degrees. Seems simple, right? Apparently not, as this took about 5 days and a bunch of different flashes of code to actually, fix. I don't know why. Like, I would rotate one thing and something else wouldn't rotate. I would try and rotate that thing and it would just disappear. I eventually figured that out. And then don't even get me started on all the different prototypes and 3D prints that I had to toss because I would figure one small little thing would be wrong with them. But I tell you, when it was significantly less than the first few projects that I worked on, I mean, I used my filament so much more efficiently this time around. You wouldn't even believe how much filament I was going through when I was first starting off. Now on to what I think was the greatest mistake I made in this entire project. I used a terrible wire to take power from the main battery pack and power the whole system. And this horrible decision, along with a pretty crappy soldering job that I just wanted to just deem acceptable for some reason, because I really wanted to get into testing, it just ruined the whole screen. It shorted, and the whole screen just ended up bleh. This cost me $80. So I had to reorder a whole new screen. This is why you can't just leave things acceptable. You have to ensure that everything is safe. It's just, man. It still just grinds my gears, dude. Just knowing that I could have prevented that. But I was able to buy a new one, resolder, and buy, some new wire to connect to the Raspberry Pi to power the whole thing. And I was able to successfully solder, insulate, and ensure that it was 100% safe and I could power the whole thing with no issues. And finally, here we are, a working alien isolation motion tracker. Yeah. Oh man, this was rough. Hope you enjoyed this nice little project that I worked on. If you have a project that you'd like to see on the screen, please feel free to commission me at barronixlabs.com. I want to continue to bring these fictional devices into reality. If you want to see some more content like this, please like and subscribe. Check out this Mirage build if you haven't seen it yet, and I'll see you later.